Neil deGrasse Tyson. Quote, "The universe is not only bigger than we can measure on most scales, it is bigger than we can ever imagine. The universe has a beginning and an end, and the James Webb Telescope has finally discovered the limit of the observable universe. We have always wanted to know how big the world we live in is. We dangerously search for boundaries and truth, and in doing so, our knowledge has continued to expand. In the past, the boundary of the world was somewhere beyond the horizon. Today, we use telescopes to look into the universe for clues that show us if our universe is a finite space. Now, with the James Webb Space Telescope, we may have reached a decisive turning point in this fundamental question. Whether the universe has a limit is not the question. It surely does, but we do not know if this edge is indeed the end of the universe or creation. An edge could also be a threshold leading into another universe or previously unknown dimensions. Even our Earth has an edge, as does the solar system and the galaxy. However, the cosmos does not end here. Neil deGrasse Tyson is absolutely right. The problem of the size of the universe is in our heads, not in the universe itself. The universe is bigger than we can imagine. We can only search for the beginning and the end in distance or time, and to do so we use relatively modest instruments. With our telescopes, we are currently observing about 46.5 billion light-years in every direction, which means we are observing a total diameter of about 93 billion light-years. So far, there has been no end in sight, and the mass of stars, galaxies, and phenomena we have found in this area goes beyond imagination. It would take thousands of years to explore and investigate every corner of the universe we already know. However, driven by insatiable curiosity, we continue to search for more. We want to know if the universe has an edge and what it looks like, and the James Webb Space Telescope should finally show us this edge. The universe has a beginning. Neil deGrasse Tyson, quote, "The James Webb Space Telescope identifies objects in the dark era that, according to our best measurements, are large, fully developed galaxies. We humans have a simple mindset. For us, everything has a beginning and an end, and we usually think in terms of facts and figures and spatially limited and confined structures. However, anyone dealing with the universe soon encounters the limits of thought and perception. To understand the incredible dimensions of the cosmos, most of us must overcome the limits of our perception. The vastness of what we have seen so far, the number of stars, the countless planets, and the strangest cosmic phenomena push a narrow and limited mind to open up. In general, astronomers and cosmologists should be among the most open and free-minded people, or so one might think. But our scientists today must realize that they are still quite limited, and that they may have thought within boundaries that prevented them from recognizing the truth of the universe. The James Webb Space Telescope is pushing our space researchers to their limits. Theories and truths are faltering, and it is very likely that our worldview will take another leap, as it did hundreds of years ago when people realized that the Earth is round and not a disk. James Webb shows us 6 galaxies so ancient and perfectly developed that they should not exist in the observed era. The JWST was designed to observe the dark ages where the first stars formed, but instead of showing us the protostars and nascent galaxies that were expected, the telescope offers us rows and rows of perfectly formed, very old-looking galaxies. So are we really looking at the beginning and thus the time limit of the universe? And above all, did the Dark Ages really exist, or did we humans invent them because we did not know the truth? The 6 galaxies are not the only shocking discoveries made by James Webb. The telescope has also found a gigantic cluster of galaxies that existed too early to exist. In galaxy clusters, millions of galaxies come together in groups, and until now it was thought that single stars formed first, then star clusters, then galaxies, and finally galaxy groups. What does a galaxy cluster existing in an era when the universe was presumably still very young tell us? Countless galaxies with redshifts greater than 10. Neil deGrasse Tyson. Quote, "The problem is not the universe, the problem is us, because we think we know more than we actually know." It sounds absurd, but the JWST is showing us even more galaxies in a period long known as the Dark Age of the universe. Almost all the galaxies found by Webb in the primordial universe have a redshift greater than 10, which means they existed when the universe was 2% of its previous age, just a few 100,000 years after the Big Bang. These discoveries do not show us a dark world but a universe that actually looked the same as today. These discoveries are so incredible that scientists initially doubted Webb's findings, but the telescope's spectroscopy has confirmed each result multiple times. Spectroscopy played a crucial role in confirming the distance and properties of the extremely distant galaxies. Astronomers use this method to break down the light of an astronomical object into its different wavelengths and thus determine the age of the light source and physical properties such as chemical composition. Webb's results have shown that these galaxies are not only very old, but also contain elements and a number of stars that do not fit a young universe. The temporal limit of the universe is moving further and further away from us. But what about the spatial limit? Have we already found it, or can we find it? Here we face a paradox, because if we are looking for something in a space that exists now, we should see this space in real time. Imagine looking for the walls of a very large and dark concert hall, except for a few small LED lights at a distance of 10 or 20 meters. You do not know exactly how big the hall is, nor can you see the walls. You would have to personally search for the edges by feeling the ground. This option is not possible for us in the cosmos because at the moment we cannot cross it personally. The other possibility is to have a telescope to look farther and farther. You focus on the bright spots, that is, where there are LEDs, because there you can at least see a little. If your telescope is good enough, at some point you might even see the walls of the room. But the tricky thing about the universe is that it moves at the exact moment we are looking with our new super telescope, the JWS, as if the walls of space are expanding while you are looking. So you have to make sure you keep up with the movement of the walls while developing the technology and reach of your telescope. Another phenomenon occurs in space that makes it harder to search for walls or an edge. Light takes time to travel through space. With the JWS, we see light that has traveled for 4 light years, 100, 1,000, or even 13 billion light years. So we always only see the past. Strictly speaking, you also see the past in your room, but the light from the LEDs 60 or 100 meters away takes only a fraction of a second to reach your eyes. So we can say that you experience space in real time. But in the universe, temporal dimensions are different. We can already see the nearest star, Alpha Centauri, as it was 4 years ago. Naturally, we can say that the universe had to be even smaller 400,000 or 5 million years ago because it had not expanded so much yet. However, we have not yet found any signs of a spatial limit. On the contrary, we have found evidence that the universe is not expanding at the same speed everywhere. This could mean that our cosmos does not have a uniform and homogeneous shape, but is structured in a way that we have not yet recognized. JWS, departure towards infinity. Have you ever thought it might be a mistake to look for ends or a beginning? Perhaps this new era of space exploration wants to show us that we need to stop thinking in terms of limited sizes to go beyond what we have considered true so far. In its own way, the JWST shows us once again that there seem to be no limits even within the universe. Once again, the telescope has found structures that break boundaries, and it wasn't even about looking for an edge. James Webb observed a distant galaxy and found a galactic center so large that scientists were left speechless. At the center of this young galaxy, only about 570 million years after the Big Bang, a quasar with a black hole 10 times the mass of our sun was already raging. Black holes that are part of an active galactic nucleus emit an unusually large amount of light, produced by the friction of material spiraling towards the black hole. These galactic centers shine trillions of times more than the brightest stars. Even in its search for exoplanets, the JWST constantly shows us that we need to stop thinking in terms of limits. We need to aim for diversity and infinity if we truly want to understand the universe. HIP 6E5426b had already been identified by Hubble in 2017, but now, thanks to Webb's unique new capabilities and highly sensitive spectrometers, we have even clearer data on this distant world. HIP 65426b is a huge gas giant, about 12 times larger than Jupiter. It is located at a distance from its star 100 times greater than the Earth-Sun distance. This is more than double the distance of the dwarf planet Pluto from the Sun. Using Webb's coronagraph and various filters, this planet was directly photographed for the first time, which is an absolute exception since most exoplanets are discovered by transiting in front of their natal star, or by indirect methods. These are just two extremes and two further examples of the fact that we have to deal with the fact that there are so many phenomena, particularities, exceptions, and ever new dimensions to discover in the universe that it would be really foolish to look for an end, boundaries, or limits. Like and subscribe to the channel and participate in every new video.